Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video, I will solve an application problem using normal distribution and in particular Excel to compute these probabilities. So let's go ahead and take a look at this. Now that we know how to use Excel, we're going to go rather fast. But let's see what we have. We have the weight of male babies that are less than 2 months old in the United States. The weights are normally distributed with the mean of 11.5 pounds and the standard deviation 2.7. Okay, so that's the critical information that we need to highlight. This is how you would know, okay, I'm using normal distribution to answer all of these questions. Okay, the first one says, what proportion of babies weigh at most 9 pounds? So I would go ahead and make a little sketch here of what your problem is asking you to do. We know that the mean is 11.5, okay, and we want to know what proportion of babies weigh at most, which means no more than 9 pounds. So we actually ask to find the area under the curve from -infinity up to 9. Okay? Once you make this picture, it makes it a lot easier to see, oh, okay, I know what I need to plug in into Excel. So let's go back to our Excel file. And I want to see what proportion of babies that weigh at most 9 pounds. Okay? So I need to find the area under the curve, normal distribution from -infinity up to what? 9. Now my mean is no longer 0. It is the mean that's given in the problem, which is 11.5. The standard deviation is 2.7. And this is still cumulative, so we can say 1 or true. We get 0.1772. So as far as the proportion goes, it's roughly 17.72%. Okay. All right, let's see. Next question says, what proportion of babies weigh at least 13%? Oh, 13 pounds, not percent. Okay, here's 11.5. 13 should sit somewhere here. I want to find this proportion, right? How would I do it? Remember, my Excel command will compute this probability or this area under the curve. So I need to do 1 minus. Okay? So let's see. At least 13 pounds would be 1 minus normal distribution from -infinity up to 13. The mean is 11.5. The standard deviation is still 2.7. And yes. Okay, let me just check all of my parameters. This is from -infinity up to 13 pounds. That's at most 13 pounds, right? Mean, standard deviation 1 minus that will give me at least. So we get 28.93%. That's going to be our proportion here. So 28.93%. Okay. All right, let's take a look at the next two. Find the 85th percentile of the baby weight. Okay. 85th percentile. So that is the weight of a baby that cuts my distribution into what? 85% to the left and 15% to the right. Okay. So what do we have to the left? 0.85, right? That's what we need. Okay, now this one is asking for percentile, so think about it as normal inverse, not the CDF, right? Not the cumulative distribution, but the function that returns the value on the x-axis. Okay, All right, let's see. So we're gonna go and say this is norm inverse. Probability to the left of that value is 0.85. The mean is 11.5. Standard deviation is 2.7. Okay, let's just double check all the values. 0.85, 11.5, 2.7. We should get a value that's bigger than the mean, right? This is 85th percentile. These are babies on the heavier side. Okay, 14.3 pounds. That's what this is, right? This is 14.3 pound. Okay, and that makes sense because this value is higher than the mean. Similarly, the 20th percentile, these are the babies that weigh a little less, right? Okay, these are the smaller babies, so this would be 20th percentile. So the weight that cuts the distribution in bottom 20 and top 80%, same as before. This is normal inverse. Let's go ahead and do that one. So actually, I'm just going to drag this down and change one parameter. I just need to change the probability to the left from 85. I'm going to change it to 0.2. Okay, I should get a value that's a lot less than the mean. These are the lighter babies. So 9.2 pound. Okay, 9.2. That's going to go over here. And let's see, what about the last one? What proportion of babies weigh between 8 and 14 pounds? Let's go ahead and take a quick picture. I'll make a quick picture. Let's see. We have 11.5 that sits here, 14 to the right, 8 to the left. Okay, so it's the percentage of babies that weigh between 8 and 14 pounds. Let's see how much we get. Now remember, we have to compute two areas here and subtract one from the other. So we're going to compute the bigger one, subtract the smaller one from it. Okay, let's see. So what would I do here? It's normal distribution. I go up to 14. The mean is still the same. Standard deviation is 2.7. 1. That is what? That is the area up to 14, right? Okay, so it's this piece right here. I don't need that piece. I need the green one. So I'm going to compute the one up to 8 pounds. Okay, so then we're going to do minus normal distribution 8, 11.5. Standard deviation 2.7, 1. Okay, and we get 72.5%. So 72.5%. That's our final answer. All right, so now you can see how we can answer questions that are not just generic questions about z-scores, but these are application problems, right, where we would have a problem with a context that we can actually be interested in, and using this information we can answer a lot more questions. And it's very simple with using Excel. You see how it's really not complicated. Just follow the command, use the syntax correctly, make sure all of your numbers plugged in the right order, and then you guys will be fine. Okay, thank you for watching.